Hey guys, so I decided that rather than going through a whole paper, I'm just gonna go through questions that either I find hard or someone else told me they find hard, right? Because I can't be asked to do the paper stuff. Also, shout out to Bill 820. Yeah, this video and the next few ones are requested by her. So she asked me to do the 2020 paper, I think it was paper 1, from question 11. So the first one is a circles question. So what do we have to do? Part A, we have to show that the angle AOB is that. Okay. So first thing we want to do is find out what the points A and B are, which we can do by equating the equations for C1 and C2. So there's two ways you could do this, I guess. You could either rearrange one of these equations for y, because it's in both, right? And then sub it into the other one, and then solve for x. Or you could rearrange both of them for y, and then just make them equal to each other to solve for x. I'll do what should I show you? I'll do the first way. So let's rearrange the first equation to be to make y squared the subject. So if we make y squared the subject, we're going to get that it's equal to 100 minus x squared. And then we want to sub this part into the y squared in the second equation. So if we do that, we have x minus 15 squared plus 100 minus x squared is equal to 40. Now you can expand the brackets out, which if you do, you'll get x squared minus 30x plus 225, then plus 100 minus x squared equal 40. There's an x squared and a minus x squared, so those will cancel out. And then we'll have minus 30x plus 325 is equal to 40. Since there's not any x squares or anything, we can just rearrange this to be in terms of x, which if we do... Oh wait, let me use a calculator. Oh wait, so then 325 minus 40. Okay, so we have 285 is equal to 30x, and then 1 million. I'm doing that divided by 30 to get x, so x is equal to 9.5. Okay, and this lines up with the diagram because we can see that they both have the same x coordinates, right? Now we need to find the y coordinates, and to do that we can sub this x value back into either of these equations. I'll just do it to the first one. There. So if we do that, we have 9.5 squared plus y squared is equal to 100. So we want to solve for y, so if you rearrange this, where's the answer one? Yeah, so you get that. And then we want to square root this. So when we square root, we get plus or minus. For this one, it would be wait. So it's plus or minus root 39 over 2. Okay. So that means that the length from the x-axis to A and to B is root 39 over 2. So if we want to find this angle, you can see that like it's like a triangle, right? So wait, hold on a minute. Okay. So yeah, is here and then is up. So we know that this is right. So these are both root 39 over 2, and then the x for them is 9.5. So that means that these are both the same triangle, right? Which also means that if we're trying to find this angle, it's basically the same as just finding one of these angles in the triangle and then doubling it, because these are both the same angle since they're the same triangle. So if we look at it as one triangle, we get this.
Hi.
Hi.
Hi, this one.
Okay, and then if we want to find the angle here, we can use tan. So that would be like this one. So we have to do tan inverse of root 39 over 2 divided by 9.5, which is oh wait, this one's in degrees. Do I know how to switch it? Yeah, I don't know how to switch it. That? Nope. Nope. Okay, no. I'm just gonna use my calculator like nuts in my hand. But I'm basically just writing this, but my calculator's got it in radians. So no. So this is equal to 0.31756, blah blah blah. Okay, so that's one of them. The angle that we're trying to find is twice that, so we want to double this. And if you do that, you get 0.63512, blah blah blah. And then to three significant figures, that's 0.635, which is what the question said. So, yeah, that's why you do that one. And then for part B, okay, for this one we need to find the perimeter of the shaded region. So that's basically all of the circle part minus the bit that would be like here normally between A and B. So so since in part A we found the angle A and B, there's probably a way that we can use that for part B, right? So how do I show this? So if you imagine that you actually drew out like the whole of circle 1, right? And then imagine that like this is where A and B are, right? And then let's say that's the origin. So when you draw the lines like from the origin to A and B, to make the triangle that we used before, and then found the angle from right. That's also basically the same as like finding the angle of this sector, right? And this is useful because the arc of this sector is like part of what we're moving from the area of the circle. So all we need to do to find like this area, well, there's two ways. You can find this angle and then do the arc length of the sector like format, so the arc length, it's just r theta. So you just do the radius times whatever this angle is, or you could do the normal area of a circle equation, which is 2 pi r, and then just take away that arc length. So, I don't know, let me... I'll do it this way by taking away the length bit. Okay, so if I do that, first I'll find the whole circle. So for circle 1, the radius is going to be the square root of 100, so that's going to be 10. So 2 pi times 10, which is 20 pi, that's for the whole circle. And then the arc length over there, it's going to be r theta, so the theta from part A was 0.635, so we're just going to do 10 times 0.635, which is 6.35. Yeah, I think it's fine to just use the rounded version of it rather than using like all the decimals. And then, so that's to find this perimeter. To find this perimeter, you can try and do a similar thing. So we can't use the same angle because this was the angle from this origin to A and B. And we used the origin because that was the center of this circle. See, there wasn't like any changes to y or x. For this one, we can find the angle by finding the center of the circle. So that would be 15 for x and then 0 for y. So I'll do it here. Oh, wait, I guess I don't need to draw the circle, but the triangle part. I'll just draw the top half since they're both the same triangle. So, we know from part A that like the y of this isn't going to change, so it's still going to be with 39 over 2. The x is going to be, so we know like, okay. We know like from the origin to where A and B are, that's 9.5. And then the center of the circle is 15. So this vector is going to be 15 minus 9.5, which is 5.5. And then we can find this angle in the same way as part A. Sorry, not that angle, only like this whole angle. By finding this one and then doubling it. So that's going to be tan again, so it's going to be the inverse tan of root 39 over 2 divided by 5.5. I'm going to use my calculator again. So that's... Okay, so that's 0.516 blah blah. Then we times it by 2, which is 1.0327 blah blah. Okay. So that is the theta here. basically. And then we can do the same thing that we did over here. So you can either find that angle and do that one, or do the sector thing. I'm going to do the sector thing here. So, for the whole circle, this one has the radius squared is 40. So, this one's radius is going to be root 40, which is 2 root 10. And then the arc length is so the arc lengths are 2 root 10 times the theta value. I'm going to do that on my calculator. So it's like 6.53 blah blah. Oh wait, and then the area of the whole circle, that's 2 pi times 2 root 10. So that's 4 root 10 times pi. And then what's it? We're taking the arc length away from that. So that's going to be minus 6.53. Okay, so that means that we found the perimeter of that bit, we found the perimeter of that bit for the circles. So now we just need to add this together. Where'd it go? Okay, so we need to add that. Oh, I didn't write it out properly there. Okay, so the whole perimeter for like just that bit here is 20 pi minus 6.35. Okay, so to find the total perimeter, we're gonna add this and this one. So that's okay. 20 pi plus 4 root 10 pi minus 6.35 minus 6.53. I'm gonna put on my calculator. And that is 89.690 blah blah. The question said to give it to one decimal place, so that means, did I say it right? I meant perimeter. The perimeter is going to be 89.7. Let me check the mark seam. Okay, wait, so I think, yeah, okay, they did it a different way in both parts, actually, but you still get the marks, because like, I think that was a valid way to solve them. And then, in this one, yeah, in this one they did the way where you find this angle by doing like 360, so 2 pi minus the angle that we found in part A, and then finding that arc length without like minusing it. Okay. But we still got the same answer, so I think it's fine.